So in this problem we have a hatch door and the hatch door is held up by a strut here. So we have a strut at AB. We have a strut AB, and the diameter of the hatch door is 1 meter. So this is a hatch door. Hatch door, and we have a strut here. Strut that is holding this up, the hatch door, and we have a hinge here. Okay, so this strut AB of this 1 meter diameter hatch door exerts a force of 450 Newton on point A. So we are having a force on point A of 450 Newton. Determine the moment of this force about point O. So that our hinge is at point O. So what's the moment of this force around point O? So if you remember the moment of a force about a point, so recall that we have a force F, and that's the line of action of F, and we have a point O here. So to find the moment of this force about point O, there are several ways. There are various options there for finding the moment of force F about point O. So you can use any position vector from point O to the line of action of F, any. So that and that you should also recall that moment O vector is cross product of any of this R, so R1, R2, R3, and then Rn. Okay, so Rn. So any of these position vectors can be used times F. So remembering this, you can go ahead with the solution. Okay, so the problem on the problem drawing, we can see that we have we can use for R O vector OB, and this would be R OB vector. So that can be used because this is on the line of action of our force vector. So that's the line of action of F vector. Also, we can also use a OA. Okay, so as a position vector, we can use ROA vector. So we can use either ROA or ROB, and both of them should give us the same result for moment O. Okay, so let's go ahead with the solution. Right. So position vector and force vector. So we need to write position vector and force vector. So we need to write them as Cartesian vector. Okay. So let's go ahead and write ROB. That would be equal to, let me just copy and paste the picture here. So I will copy and paste the problem drawing here to make reference. right as. So that's my X, Y, and Z axis. Let's just delete these. So this is my X axis, Y axis, and Z axis. So point O coordinates 0, 0, 0, that's the origin. And I'm having point A, and I'm having point B here. So which are defined by some angles or by some distance values. Okay, so let's go ahead and write ROB vector. So that will be equal to 4 for X component we have 0 minus 0 for ROB, because note that in point B lies on the 0 and from like it lies on the y-axis, so X coordinate of B is 0. Okay, so that's 0 minus 0 I plus, and the y coordinate for B would be, and so this is 1 meter, that's the length, and the projection of this 1 meter, so that's 30 degree, so 1 meter times cosine 30, so cosine 30 would be the projection, so that would give the y coordinates for B, so 1 times cosine 30 and minus 0 J, and for the K, for the Z coordinate of B, so which would be this one, so this is here 1 meter times sine 30. Okay, so 1 meter times sine 30 minus 0 again, and that's K. So my ROB vector is going to be 0.866 J plus 0.5 K meters. Okay, so let's go ahead and write a ROA. That will be equal to, using a similar approach, we're going to be having for the X coordinate, so A is here and the X coordinates, so this is again a 30 degree angle here, so again 0.5 times sine 30 and 0.5 times cosine 30 would be the X and Y coordinates of point A. Okay, so based on that I will be having 0.5 meter times sine 30 minus 0 I plus 0.5, for the J coordinate it's 0.5, for the Y coordinate it's 0.5. That is easily seen here. Okay, but sorry, for Y I'm gonna have like 0.5 plus 0.5 times cosine 30 here, yes? So I'm talking about this coordinate here. So where y-axis is sitting, so that's 0.5 plus 0.5, so that's 0.5 meter, and that is 0.5 meters times cosine 30 degree. So plus 0.5 cosine 30 degree and minus 0 J plus, so point A lies on the xy plane, so Z is 0. Z coordinate of A is 0, so 0 minus 0K. So I end up with ROA vector is 0.25 I plus 0.93 J. Okay, So these are my, so this is my ROB, and that's my ROA. Okay, so that's ROB and that's ROA, and both can be used for calculating the moment of force vector around point O, as discussed above. Okay, let's go ahead and write the force vector as a Cartesian vector. So using the okay, so we can write force vector by writing a unit vector along the force vector's line of action. So let's paste the drawing again. Okay, so let's emphasize the line of action of my force vector. So that's my force vector's line of action. Okay, so I need to write here a unit vector. Let's use this color. So a unit vector along this line. So I need a UAB unit vector. Okay, so I know the coordinates of B, I know the coordinates of A. I used to calculate ROB and ROA. So I can use those coordinates and write my force vector F as U as the magnitude of the force vector times UAB unit vector that is along the line of action of F. Okay, so we need to write this one. So that one is given 450 newtons. Okay, so we need to write this UAB by using coordinates of B and coordinates of A. And essentially we're going to subtract B values from A values, like I minus J minus K of A. Okay, that's the approach, if you remember. So my force vector will be equal to 450, so that will be a long equation here. Okay, so we're going to be subtracting the coordinate values of B's from A's to B to write the UAB vector will be RAB vector over the value of RAB. Okay, so essentially I will be writing up here my RAB vector. It will be a bit long, so that's 0.0 minus 0.5 times sine 30, and that's I, and plus 1 times cosine 30 minus 0.5, okay, plus 0.5 times cosine 30, cosine 30j. I am running out of space here. And plus 1 cosine 30, 1 sine 30 minus 0, and that will be k. Okay, so that will be, so this one is j, sorry. Okay, so that one will be, like 2 parentheses j plus, and you know the square root of the I value squared plus the j value squared plus the k value squared, which I've just written up here. So that's the I component, that's the j component, and that's the k component. So you take the square of them, add them up, and square root. So I end up with this force vector here, which is minus 199.82 I minus 53.54 J plus 399.63 K. So that's my force vector here. Okay, so that's the force vector, and to find my moment about point O, I need to multiply a vector or AOA cross product force F, or I can use ROB and F. Right, so if you remember, this one can be found by using a determinant. So I'm going to be having an IJK up here, and then 0.25, 0.930 here, and minus 199.8, and minus 58, 53.5, and 399.6. Right, and again, this can be calculated by a determinant of a matrix, and the elements of that matrix will be IJK 0, 0.866, and 0.5, and for the force I'm going to be having 199.8 minus 53.5 and 399.6. So both of these will yield the same result. So moment point about O will be 373 I minus 99.9 J and plus 173 K, and that's Newton meter. Okay, so that's the solution. That's my answer. Thanks for listening.